This video we discuss about expectation, the moments and the variance of random variables. The expected value or mean value of a random variable is defined as ex is equal to ux is equal to integral minus infinity to infinity x fxx dx. It means it is the integration of the random variable x with its PMF and integrate between values minus infinity to infinity. This can also be indicated as mx is equal to ex is equal to mu x. This is for continuous random variable. In the case of discrete random variable, the expected value is given as ex is equal to, instead of integration we are using summation over all values of x, the product of x, px, x. So it means we are taking the summation over all values of x, the product of x and pxx. Pxx is nothing but the PMF, that is probability mass function, whereas this is for discrete random variable. In the case of continuous random variable, it is integral x fxx dx, where fxx is the PDF, probability density function. This is the difference between CRV and DRV. In the case of CRV, we are using PDF. In the case of DRV, we are using PMF. In the case of CRV, we are using integration. In the case of DRV, we are using summation. Now we define moments. The nth moment of random variable is defined as e x power n is equal to integral minus infinity to infinity x power n fxx dx. As we have seen already, that if you want to compute expected value of any argument, then you are multiplying this argument with its PDF and integrating it. So same definition, we are extending it for moments also. Moment equations are generalization of the expected value and other powers of random variable. So here, this general equation e x power n is given as integral x power n fxx dx. Suppose if you keep n is equal to 1, then this becomes x fxx dx. That is nothing but, suppose if I keep in the place of n 1, then it becomes e x is equal to integral minus infinity to infinity x fxx dx. This is nothing but ex. So for n is equal to 1, the first moment, it is known as first moment, is reducing to expected value itself. So n is equal to 1 is first moment of the random variable, that is expected value. If n is equal to 2, then it becomes e x square, that is in the place of random variable we are using x square fxx dx. This is nothing but PDF, probability density function. Multiply x square with its probability density function and integrate it, you get ex square. Now observe it here, this is nothing but the expected value of square of the random variable. That's why it is known as mean of the square value of x. That's why it is mean square value. So these two values, expected value and mean square value of random variables, are very important to understand the continuous random variables. So first value or first moment and second moment of the random variables are also known as expected value and mean square value. If n is equal to 1, it is expected value. If n is equal to 2, it is mean square value. Now we define central moments. The central moment is moment of the difference between random variable x with its mean value. If it is raised to the power of n, it is known as nth central moment. So the general equation for nth central moment is given as e x minus mu x whole power n is equal to integral x minus mu x whole power n and fxx, it is PDF. So we know this equation already. In this, whatever argument is here, the same one is substituted here along with its PDF. This gives us nth central moment. Now, if I keep n is equal to 1, then what happens? This equation reduces to expectation of x minus mu x. What is its value? It is nothing but ex minus mu x. This says these two values are same, expected value and mean value are same. That's why it is 0. If n is equal to 1, the central moment is 0. Now if n is equal to 2, then this equation reduces to x minus mu x square. Now the integral is written like this, x minus mu x square into its PDF. So this is known as second central moment, or it is also given a particular name known as variance. Variance x is denoted as sigma square x is equal to this expected value of x minus mu x square. So the second central moment is also known as variance x. So therefore expected value and variance x are very important factors that describes the random variable. In the previous slide, we defined variance x. So variance x is written as variance x is equal to expected value of x minus mu x whole square. So this is a minus b whole square. If you expand it, you get x square plus mu x square minus 2x mu x. And if you simplify it, we get variance x is equal to ex square minus mu x square. So variance x can also be alternatively found out as the difference of mean square value minus square of the mean. So variance x is equal to mean square value minus square of the mean. And suppose if mu x is equal to 0, that is mean of the random variable is 0, then variance x is simply equal to, variance x would be equal to ex squared in case of 0 mean value. So this equation helps us in certain conditions where the mean value is 0. And then how we understand variance? Variance is measure of variable's randomness from its mean value. Now suppose if I draw PDF is something like this, a bell curve, and this indicates the mean value. And how we understand the variance? It is the effective width from its mean value or a measure of its randomness. We take one example here. We'll consider uniform random variable and then we calculate its mean value and its variance value. First we understand what is uniform random variable. If the PDF is uniformly distributed, if fxx, that is PDF, probability density function, is uniformly distributed between the intervals a and b, then it is known as uniform random variable. Now we can see this diagram wherein the PDF, the probability density function, is uniform between a and b. Here it is constant. That's why it is known as uniform random variable. For this particular uniform random variable, we calculate its mean value and its variance value. We are calculating the mean value of uniform random variable. For the convenience, I'll draw the uniform random variable. It is something like this. Between intervals a and b, its PDF is constant. So let us indicate it as k. It is constant. And this is fxx PDF. Now we find the value of k. What is the value of k if it is uniformly distributed? We know from the definition integral fxx dx for all values of x is equal to 1 because the area occupied by PDF is 1. And we know between the intervals a and b, the PDF value is k as shown here. Therefore, we find the k value as 1 by b minus a. Therefore, this value is 1 by b minus a. Now, after finding this, now we can readily find out the expected value ex is equal to integral minus infinity to infinity x fxx dx. Now we substitute the values here in the place of k and simplify the integral. We get b plus a by 2. It is very simple calculation. So expected value of uniform random variable is a plus b by 2. We can readily observe even from the diagram also. It is mean value is a plus b by 2. It is center of gravity here, center place. Therefore, the expected value is b plus a by 2. Next we are going for variance. Variance x, we already seen the equation, the simplified equation as the mean square value minus square of the mean. This is the equation for variance. So now to find out variance x, we need to calculate the mean square value first and then mean value. Mean value we already know, that is b plus a by 2. And if we calculate ex square, then we can find out variance x. Therefore, first we are trying ex square, that is mean square value. As per the definition, we know it is integral x square pdf dx. And substituting the values, we get the ex square as a square plus b square plus ab by 3. This is mean square value or ex square. Now we are calculating variance x of uniform random variable. We know that variance x is equal to ex square minus ex whole square. That is mean square value and square of the mean value. And we calculated mean square value as a square plus b square plus ab by 3 and mean value as b plus a by 2. So square of that is b plus a by 2 whole square. And then if you simplify, you get variance of uniform random variable as b minus a whole square by 12. So it is always easy to find out variance in terms of its mean square value and mean value. Find out its mean square value and mean value, substitute in this equation, we can readily calculate variance x. So in this video, we started with expected value, we defined expected value, and then the general definition of moment is discussed. We have seen what is first moment, that itself is mean value, and second moment is mean square value, and then we defined central moments. And from the central moments definition, we understood that the second central moment is nothing but variance x. We defined new one, variance x, that is equal to the second central moment. And then we considered one example of uniform random variable and we found out the mean value and variance value of uniform random variable.